In this section, we're going to return to our File 2 capture file. And within this tool now, we're going to take and use this powerful capability of Wireshark to display the packets with a filter. So once you open Wireshark, you can open your file 2.pcap.ng file, as I have here on my screen, and you can walk through the exercise together with me. So once you've opened it, the first thing we want to do is explore the actual filter. And right here is where you see apply an actual filter. So what we can do is just enter here ARP, which is our ARP, and then we come over here and we click this blue arrow. Now what it does is took all the packets that were in this packet capture file, and what it did is it only extracted the information of the filter. So if you look at the ARP here, you can see we just have the ARP packets display. And when you look, we've got again the ARP request, who has, in this case, the IP address 6.6.6.7, tell me 6.6.6.6. So then the response is 6.6.6.7 is at 54EE754591A7. Remember, that's how the data gets delivered. So once that MAC or physical address gets received by the requester, in this case, the first packet number 1, then the data can be delivered. So that's kind of how now we can take this complex file, or any file for that matter, once you understand the process, we can take that complex file and we literally can analyze it. So now we clear the filter just by clicking the X. All right. Now remember, we said there's different types of filters. So if we do ICMP and we hit the arrow and we apply it, now we see just the ICMP traffic. So now you can start to see with the skills we've developed and now adding in this capability with filters, now we can take complex protocols or packets that we've analyzed and break them down to a more granular form so we can do analysis to determine what's taking place on the network, be it our network or a network that we're hired to investigate. Now, next thing we can do is any protocol can be entered here. TCP can be entered here. And we apply. And now we have our TCP traffic. So now what we have is we have that TCP. And if we look here at packet number 17, we have the three-way handshake start. We have a packet going to port 21, which is the file transfer protocol server. And from that, we have a response, which is the acknowledgement of the SYN that we sent. And then the second step in packet 18 also sends a SYN to open the other side of the connection. Remember, TCP is full duplex, so it requires 3 steps or a three-way handshake to open a connection. If you look here in packet number 20, we've identified that we're connecting to an FTP server version 2.0, a 3C daemon. And this is actually a vulnerable version of an FTP server. But again, that's understanding as you get more and more knowledge and experience. All right. So now that we've defined this type of filter, so now we just go capture options. Now, when we do our capture options, you see down here where it says capture filter for selected interface. Now we click on our drop down arrow, and in this case, UDP port 53. So now what we're doing is we're going to look at UDP port 53. So we start our network traffic, and now we need to go to our browser of choice. I will go once again to Firefox. Now when we return to our capture, we only see the capture filter traffic. In this case, DNS. That's the power of the filters. So nothing displays until it matches the capture filter. Now what we have is only those packets that we set in the capture filter. Now, one of the downsides of this is there's no other packets. This is the only packets that we have saved. So if something else was there, we would miss it. All right, so we can only analyze what the capture filter matches. That's something that could be used in segments where you should never see a certain protocol. Say you have a network segment where you know you should never see FTP, so you do a capture filter of FTP. If there's ever anything in the actual packet display that could be evidence of a compromise, because you never should see that protocol FTP ever in your network trace, and that's powerful. Next up, we'll explore the characteristics of some normal and abnormal traffic. You will see how an attacker, when they attack, you will see what it looks like at the network level.